Hello, everyone. Welcome to the Wolfram U webinar series, Learning about LLMs. Today, we have the last session in this four-part series. We have with us Jofre Espigule-Pons and Timothee Verdier with us, members of the machine learning development team. Throughout the webinar series, we've been collecting questions from you. And today we brought in our experts, Jofre and Timothy, to help us answer some of those questions. So I'll let them get started with the answering of the questions. But let's get started today. I'm going to hand it over to Jofre.
Thank you, Rita. So from last week, there's this new blog post from Stephen. So I want to start with showing the blog post that he wrote on these LLM new functions that I presented last week. Some of them, and I think here it's a good read for a good introduction to these new LLM functions. And with that, I think I will go to the question list. So I think the first one, like Joanne was asking for an elementary explanation on the syntax for these LLM functions. And on the page for the Padlet, there is also the documentation page and the usages for each of these new LLM functions. Yeah, you can go to each of them and see some basic examples on usage. And then in this other question, I will let Timothée answer.
Timothy, you're muted. Sorry.
Oops, my bad. Hi, everyone. I'm Timothée from the machine learning team. And I will... so about the point of embeddings, large dimension embedding, I think the main points that you can make in order to understand how it may help in actually optimizing the architecture to solve the problem is that it lets you a great flexibility with all those dimensions to encode your information, and that's really what the system needs to learn. Initially, historically, it was deemed hard to optimize big networks, and one feeling in the field was that the largest the dimension, the harder the optimization problem will be. And it turned out that actually the more successful direction was to get to larger dimension. And one reason for that, which was not grasped at the beginning, is that when you have more dimension, you have more direction you could escape through, and not get stuck in something that is far from being a good minimum. And when you reach a minimum, even though it's somewhat a local one, in those large dimension problems, then you're sure it's somewhat some well-behaved one, quite flat. So it was counterintuitive, but that's really what's working. But you have, on the other hand, the issue of overfitting, like in a regular fit problem, when you have many weights to store your data. You could basically encode all your training example and somewhat learn by heart the results, and so all the regularization techniques like dropouts, early stoppings, and many other which are in the toolbox of neural network trainings come into play. So the idea is to have a large model that would likely overfits your problem, and then to kind of make it more and more regular with a regularization technique, and that's what's most likely to work according to the experience we had in the field.
Thanks, Timothy. I think the next one is also technical, and it's about using some remote services like Amazon Web Services or Google to train some.
Yes.
Yeah. Also, just a note on the Wolfram Cloud, right? Go ahead. Sorry.
Yeah. So for the actual training, even though that's probably not the main point on the. Just from sorry, I had the message that jumped on. To complete this question, can mathematical machine learning use the computer power in other clouds like Amazon Web Service, Google, or is it limited to Wolfram Cloud? That's exactly the question here. First of all, regarding Wolfram Cloud, we don't offer yet specific training solution like training on GPUs or TPUs. Which are specific chips dedicated to the neural network trainings, with highly parallelizable computation. But you can obviously use a remote kernel and send any jobs you like. We don't have straight from front end direct solution to connect to those external services. So you'll have to configure things a bit, and I think the main the one big example, which is basically what we have been using internally, is something like connecting on AWS and training on the GPU machines. One probably point to start is if you have an AWS account, is to link it with AWS batch. You also have a S3 link packets that let you move data from Wolfram locally to the AWS service, where it can be seen by the machine. At least that's what we are using, and then you can basically write down a training script and submit it to the machine for in the case of AWS batch for a single execution. We don't yet have more than this to offer, and there is I think also a question of what type of architecture you want to target, TPU or GPU. That really depends on the problem that you want to train, and that's a bit trial and error case to make. Well, if you want to go to the very basics, you can connect directly to the machine, get your installation manually, and use command line and Wolfram script to perform your training.
I'm just pointing that there is a documentation page for the Wolfram script if you want to get started with it. Yeah.
And obviously how much effort you want to spend on those low-level tools depends on how long and intense you want to train, which basically there is the entry ticket for LLM is quite big because they are actually large, very intensive, and they make sense only if you have a somewhat huge amount of data to train. unless you kind of reuse an already trained model and fine tune, which is really what you should in most cases aim for. And this doesn't necessarily require very intense computation if you unless you kind of want to retrain the full architecture. But if you just want to fine tune, you can target just specific layers. If you want to train locally, which is basically not really what you could do with large models such as LLM. Many LLM will probably not fit on your CPU unless you have a very powerful CPU. So you would probably have to move to GPU. Just make sure if that you have some standalone GPU, because if you try to load your model on the GPU that's also controlling your screen, you probably will experience some troubles, obviously. And the GPU are dramatically faster for training. So as soon as you come to serious trainings, that's the way to go. Or even specialized TPU if you have access to them. So if you and basically if you train locally, or if you, which basically is what you eventually end up if you train remotely, what you need to play with is target device goes to, and then CPU, GPU, and if you have several GPU, you can use GPU a list with GPU 1, 2, 3, 4, whatever, or all if you have them. If you want to use all the available GPU on the machine. So. License plans. So the current system for training, if you use a remote service, we currently don't, because it's not on our premises, on our cloud. We currently don't offer a specific licensing plan. Well, you have basically two options. Either you use, if for instance you want to use Amazon, you can use Amazon Marketplace to get the Wolfram machines that is ready to use there, and you will pay the licensing through your Amazon accounts, or you can also install your own Mathematica license on the machine, and like any machine that you rent, and use a standalone license. For the rest, then it's for like heavy commercial use. There's probably a direct commercial discussion that you can have, but it's not on my side and on my part. Experience, insight from actual use case of training GPU on AWS, Azure, GCP. I would not. I am sorry. I won't have a lot of benchmarks and comparison information for those different providers, because we did train and work with Amazon, and main reason was they were the first there. Easy to work with when we started the training, so mainly historical, and then we had a working workflow. So yes, I cannot compare between all those different providers. But we did do a few, quite a bunch of trainings on Amazon. Okay, maybe then Jofre, you can
for the next
on
question.
to the next question.
So Conrad asked, how would one migrate Python code into Wolfram language? This is just an idea, but I would use this LLM example function and create a bunch of examples from kind of Python code. Here I have one example on natural language to Wolfram language code. So the only thing that you would need to change is for converting, you would give your Python code example and then the Wolfram language translation, or like in kind of conversion, and try to see how good are GPT 3.5 or GPT-4 for the conversion. Future learning, it works quite well. So giving a bunch of examples from kind of your code might help on converting code pieces. But yeah, that also depends on the type of libraries that you're using on Python. For the next question, I think on the neural net repository, we have the GPT-2, it's open. GPT-4 and GPT-3 and GPT 3.5 are not open yet, but one can access them via the OpenAI API. So that's that will be like LLM synthesize or LLM example or function or LLM function. You can access these models there. And yeah, I think I showed some example on extracting certain entities from text in my notebook. I think I have one on Wikipedia data and then extracting, for example, certain dates and entities of presidents. There was one on specifically on extracting personal data from a Wikipedia entry. That could be like also other type of text, and that would be giving certain examples on the type of entities that you want to extract. You would use the LLM example function, and it would already do a nice job on this task. Yeah, Jefferson is asking on for like what are good data sets to train a scientific language. I just found this kind of data set on archive papers that it's highly graded, and maybe it's a good place to start. I think that they're like most of the papers there in a nice structure. So maybe that would be a good place for like getting the training data on such type of scientific jargon. Right. So yeah, I think I tried to kind of generate some neural network functions, Wolfram neural network, kind of Wolfram language functions on a specific machine learning functions. Sometimes does a good job, sometimes thoroughly like hallucinates and creates new built-in functions that do not exist. So take it at your own risk. You can experiment and ask to build up, to write down some code, and sometimes works, but just take it at your own risk. Right. Martin is asking for a specific example to generate Wolfram language code. This example uses the LLM example function. And in this case, I'm using only one example, the so-called one-shot learning example from natural language. I give the answer, And with this example, since we won the code without being evaluated, I'm using in the interpreter section held expression. This would prevent the code that generates the LLM to not be evaluated. If you are interested more in the result on the computation of integration, then you can use to expression, for example. Or an alternative could be also to just get the string and then you modify the code at your will. So for example, here the default one is a string, so I guess it would generate the same answer, but as a string. If I say like, you can see that it's in quotation marks, so it's not interpreted as a Wolfram expression. Right. That would be like different ways of generating kind of Wolfram language code from examples using LLM example function. One trick that one can use is to also in the examples to add the hold. So whenever you interpret the expression, the string, you would obtain the expression as with a hold, an evaluated expression. So then you can use a release hold, and you would get the kind of deployed code result. And at the end, we have another question on why was not working the LLM evaluator for model GPT-4. This might be on the type of license that you have. I think GPT-4 is not fully open access to every user. I might be wrong, but I think that's the case, that the default one is GPT 3.5 Turbo, which is the default ChatGPT one. And I don't know if there is some more live questions, Timothée.
Yes, we do have some live questions. So Timothy, do you want to pick those up?
I can.
Yeah. So
or
what? So this question that maybe I get wrong, but it's saying is about ChatGPT is nice and does all the things. How can one create a LLM with their own personal data by telling everything about my life? And if I was writing a biography about my life, I think that I'm not sure I actually get the point here in terms of what you want to do. One confusion that it would be nice to discuss about is whether or not the point is to provide the data at training time. The big power of large language model is that indeed they learned a lot about the language structure and also stored a lot of what we would call common sense knowledge, so that they can reinvest all those learned skills into new tasks. So you don't need to retrain language model, especially large one, because most of the time the amount of data is very, very huge in order to generate those networks. But you can still provide, and that's all about what prompt engineering, LLM function, and LLM examples, function example are about, which is to add some extra information at runtime, at evaluation time, that would provide the starting points and the elements of the answer generation. So if you want most of the time, if you want the network to generate accurate answer based on extra information, you really don't need and shouldn't retrain you should use such a pre-trained network that knows a lot about the language and about just common facts, and just provide in your prompt the elements of that are needed to answer your problem, or answer to solve your problem or answer your question. And obviously, this is going to be much faster and much less, much easier also in terms of because you don't have to actually train. So then, other question about the licensing and cost. Well, I cannot. I mean, obviously, there are a lot of competition between the cloud providers, computing power, and fees, because we are not currently like a man in the middle for this, and it doesn't go through us. It's for everyone to decide and to check in terms of how long how fast the training goes, and how good the result compared to the costs. An update about the dimensionality, saying given the name, the size of the vocabulary and the numbers of possible arrangements in terms of sentences, maybe the token embedding itself is not that big. Well, that's, I mean, it's definitely difficult to assess what the natural embedding size for an information in terms of content and complexity. Obviously, there are some problem with very, very diverse example that you can easily reduce in terms of complexity to a few dimensions by component analysis or things like that. So I feel this I feel is kind of philosophical problem to me, because I don't have the I don't have the enough information to answer more than comments. The fact that if you use too small a dimension for the embedding, your optimization at training time will go wrong, and you won't be able to solve your problem. Is a rule of thumb. And if you go to larger and larger embedding, then you will have both to use regularization techniques to avoid overfitting, which main symptoms is that your network answer won't generalize, or also use a lot of computational power and waste memory, because your model is going to be unnecessarily big. It's a point. Okay, so something about ChatGPT API tokens. No ideas how to access it through Mathematica. You mean, so if I understand it well, is you would like to get the information of how much token are somewhat available on your accounts for the how much money you can still spend on question and answer. Is that so, or it's or is it actually just retrieving the vocabulary of the LLM? But basically, we don't yet offer a link property in your connection to check on your personal information regarding how much money you have, how much free token you have, and so on. Could an LLM be created and trained by Wolfram Language? I have many records based on limited taxonomy to categorize technical data. So I think Jofre showed you that you can indeed train an attention-based language model. So large depends on what's your definitely. You could train GPT architectures using the Wolfram kernel and basically the underlying MXNet library that we link. But the big question is it the way to go? Again, as I said, it's hard to say regarding your data, but most of the time you get already sufficiently good answer on your training data with the existing model. Or what you can try indeed is to improve the performance by fine-tuning your model. But that's the difference between what's ready out of the box with the LLM function and just using the power of the LLM to extract the information you have, or to apply a pattern that you want to your data, comparing with how much investment this is to train those large models. It basically define you the way to look at those projects. The first things that you should try is use it out of the box, and that's not straightforward. That's how you could. There is already a lot of improvements that you can have by fine-tuning your prompts, by being more specific and precise about the example, the way you format the example, and also kind of bootstrap on reusing the generating the data you generate with the first trials, and then eventually if you figure out that you would like to go orders of magnitude beyond, knowing that it's not just by throwing your data in for the trainings that you will get straight an incredibly performing model, and that is going to be a lot of trial and error and tuning and changes. Then you can move to the direction of training or fine-tuning your own model. You should definitely go for fine-tuning in order to reuse all the information and the knowledge that previous general knowledge training kind of learned and embed in the model, in the existing model. And frankly, one of the leading technique for which is which is kind of the LoRa retraining and so on, are not. We don't have yet a direct workflow or tutorial on how to do that, or direct function for doing it. But that's maybe a direction we will take for the next releases. Okay, so then will fine-tuning, since this question is bouncing about what I just said, will fine-tuning the pre-trained LLM with domain-specific text preserve what it had learned and improve upon it. That fine-tuning is definitely not retraining, but it's a kind of dark art. On many cases, you can freeze part of your network and just improve by slightly changing the final layers. But especially for big models like this, with very small, usually very small data set size compared to what the initial training was, it's much more subtle than that, and that's and it's hard to kind of achieve much better results preserving the LLM state in the first trial. So there's a lot of parameters to consider and to tune regarding the new data you provide, training time, the learning rate, which part of the weights you want the training to affect. So yes and no. You can definitely fine-tuning can definitely lead to catastrophic forgetting, where you lose everything you had so far and you just kind of overfit on the new data, or if well done and there is no a winning recipe for that, let you kind of improve dramatically on the newly seen data. But that's, I mean, definitely many programs should already work well without going through those subtle and careful step of fine-tuning, because, and there is articles about it, large language models are actually very good at generating, and they are what we call in the field few-shot learner. That is, with very few examples and what they're already seen, they generalize. Jofre, do you
Yeah.
do you want to pick more question also? And
I think I would. I don't have any question that I selected so far concerning the kind of the prompts. There is gonna be actually it's already live, that the Wolfram prompt repository where you can get some inspiration on certain prompts. For also there's like some function ones that can be useful for the few-shot learning, or at least get some inspiration on LLM function and LLM example function. And also, if you have some time, try to read the Stephen's Wolfram blog on these functions. There are like some nice examples on the usage for them. But yeah, keep in mind that it's a new field and there is so much things to be explored. So yeah, I think here the limit is the imagination of the user.
Thank you so much, Jofre. Thank you, Timothee, for joining us today and answering the questions from our users. I think we will wrap up our session early today. We've had some fantastic questions, and we do understand our attendees will have many more questions. Wolfram U hopes to host many more events like this, webinars, study groups, and so on. Hopefully you will have more chances to bring your questions, especially after you've had an opportunity to try some of the things we shared with you. Try some of the things Stephen is talking about in his blog, some of the examples that we've had in the example code shared with you in the repository, in the documentation for the LLM functions Packlet, and so on. We will end our session today.